Right, so the question: to factorize completely each of the following expressions, you have x y squared minus x squared y. So when you are factorizing, you're basically taking out what is common. But this is factorizing by pulling out the highest common factor, the HCF, right? Because you just have two terms here. So look for what is common between x, y squared and x squared y. Well, I say you have to pull out the variable to the lower power. You have x and you have x squared. So I will just pull out x because x is to a lower power than x squared. And then you have between y squared and y. I'll just pull out the y because y is to a lower power than y squared. After I pull out what is common, I open my brackets and I divide each term by the highest common factor that I pulled out. So the first term was x y squared. I divide that by the highest common factor pulled out, which is xy. Put my minus sign. I write back x squared y. And I divide that by the common factor that I pulled out, which is xy. And I just simplify this, so I write back xy all over. Now you need to remember the laws of indices for this one, right? But because I have an x on top and x at the bottom, that will cancel off. Y squared divided by y, this is really y to the power 1, you subtract the powers. 2 minus 1 is 1, so you just get y to the power of 1 or just y. Same thing. Put my minus sign. I have a y on top and a y at the bottom, so it cancels off there. X squared divided by x will just be x via laws of indices. Right? So I have xy times y minus x. And the next one here, this is factorization of a quadratic. Right? This is a quadratic. So it's important that you could identify that this is a quadratic. Now a quadratic is of the form ax squared plus bx plus c. So now we're relating the general formula with the actual expression that we are given. So a is the number in front of x squared, which is 3. B is the number in front of x, which is 1. You really have a 1 in front of x, and it's a plus sign, so it's positive 1. C is the number by itself, which is negative 10. So what you are going to do now, the first step is to look for AC, the product of A and C. So that will be 3 multiplied by negative 10, which will give you negative 30. Then I'm writing B just below the negative 30 there. So B is equal to 1. So I now looking for two numbers. This is by trial and error method here. I'm looking for two numbers when added will give me 1 and when multiplied will give me negative 30. By trial and error, I'm getting 6 plus negative 5 is positive 1, and 6 multiplied by negative 5 is negative 30. So what I'm going to do here now is write back 3x squared. Instead of this x now, you need to replace this positive x from the middle here with these two factors here now. So I'm putting plus 6x minus 5x. So I must write the factors in terms of x, in terms of the variable that I have, which is x. Alright, and I need to put back the constant, which is negative 10 in this case. So now I have 4 terms. And what do I do when I have 4 terms? I factorize by grouping. So I'm going to group these terms here now in terms of pairs. Right, this is the first pair, this is the second pair here. So what is common with the first pair of terms? 3 and x, because 3 could go into 3 and 6 and x go into x squared and x. Open bracket. 3x squared divided by 3x is x. Put my plus sign back, that was in front of 6. Now 6x divided by 3x is 2. Close my bracket. I have a negative sign in front of 5x, so I'll put back my negative sign. Now what is common between 5x and 10? 5. Open bracket. Negative 5x divided by negative 5 is x. Negative 10 divided by negative 5 is positive 2. Close bracket. So I'm looking to see what else is common here now. Looking at this, the x plus 2 is common. So the remaining terms will go in my other bracket, which is the 3x minus 5. So that is my answer here. X plus 2 and 3x minus 5. Now a common question students is asked is, what if they have 3x minus 5 first and then the x plus 2 in the last, in the next bracket last? That is also correct. The order in which you write the terms in the brackets here do matter. So if you have 3x minus 5 first and then you have the x plus 2 last, that is also correct, right? Let's go on to the other part. Part B, solve for n. So it's kind of small to see, so I'll rewrite it here. You have 4 to the power of n divided by 4 to the power of 3. And this is equal to 1 all over 4. So you need to know a couple laws from the laws of indices. So I'll write it down here. So laws that you need to know of indices. Now they are like um, 5 to 6. I think you need to know for CXC maths, right? There's one or two more you need to know for odd maths, but for the ones for maths, I just write any one here that you need to know for this question alone, not writing out all. So the first one is x to the power of n divided by x to the power of m. So what we're going to have to do here now is write back the base, which is x is called the base, and you're subtracting the power, so it could be n minus m. And you should be familiar with this formula, because since in form 2, you would have done this formula, right? So you should be familiar with it since form 2. And then you have 1 all over x to the power of n. This can be rewritten as x to the power of negative n. This is the reciprocal rule. Well, this is not really a law, right? But still going to incorporate it here. If you have x to the power of n is equal to x to the power of m, since the bases are the same on both sides of the equal sign, you will equate the powers, allow the powers to be equal to each other. So equate powers since bases are the same, right? So what we're going to have here now is 4n, 4 to the power of n divided by 4 to the power of 3, and that is equal, I'm going to write this as 1 all over 4 to the power of positive 1, right? It's the same thing as 1 over 4. So I'm going to apply rule 1 to the left hand side. So I will now have 4 to the power of n minus 3. Because I'm dividing two terms with the same base, the base is 4, so I subtract the powers n minus 3. That is equal, I'm now going to apply the second rule here, the second law here, to the right hand side. So I am going to have 4 to the power of negative 1. I invert it by using the second law, right? In this case, the 4 come like the x and the n come like the 1, right? So now I have the same basis on both sides of the equal sign, so I will equate the powers. Equate powers. So the power on the left hand side is n minus 3. The power on the right hand side is negative 1. Carry across the negative 3 to the right hand side, you will get n is equal to negative 1 plus 3. So therefore n is equal to positive 2. Negative 1 plus 3 is positive 2. And that is basically the answer there. That's why it's solved for n. So this is the first time I see where you have to equate powers for maths. Normally it's a hard maths thing, but once you reach up to here, should be fine. You should get a mark for that at least, right? Um, let's go on to the next part there now. So part C, the lengths of three sides of a trapezium are shown in the diagram below. The area of the trapezium is 750 square units. So notice they didn't give you meters or centimeters, they just say square units, right? Right. So let's say well, this is the height here, right? This is the base B, and this is the top length, which we just call A. Right? Let's say write down an expression in terms of P and Q for the area of a trapezium. Now, they just give you this formula in the exam. It's somewhere here. Look, area of a trapezium is A is equal to half times A plus B times H, where A and B are the lengths of the parallel sides and H is the perpendicular distance between the parallel sides. So I mean, you have the formula there, so you could have just used that formula, right? Um, so the area of a trapezium, I'm putting A, that will be equal to half times A plus B multiplied by the height, which is H. I'm just going to redraw a trapezium here where I can input these values. So normally the bottom part is be the base A and the top part is be the length A. And this height, this difference in length, well, that length there does be H, which is the height, right? So I am replacing H with 6P. Look, I put H is equal to 6P. I'm going to put B is equal to 3Q, right? And I'm going to put A is equal to 4P. So I'm relating this formula here to the actual diagram question there. So I'm going to plug in this into the formula there now. So I have A is equal to half times A plus B is 4P plus B is 3Q times H, which is 6P. Now I have a half here and I have 6P there, so I can say 2 into 2 is 1, 2 into 6 is 3. So therefore I have A is equal, I can put the 3P first, times 4P plus 3Q. Because I was going to multiply the 4P plus 3Q by that 3P in any case. So I can just write that in front, right? So this is basically the formula there for the area of the trapezium. But let's say an expression, so I can just remove the equal sign and I will just put 3P times 4P plus 3Q. And that is it there. Now let's say given that Q is equal to 2P, determine the value of P. So we know that Q is equal to 2P, and we also know the area was equal to 750 square units. So remember, recall the formula. A is equal to 3P times 4P plus 3Q. Now what you could do here is you could just simply multiply with that, expand on this here. So you will get 3 by 4 is 12, P by P is P squared. You multiply the 3P by each term inside the bracket. And then 3P times 3Q. So 3 by 3 is 9, so you have 9 and PQ basically. So that is the area there. I am now going to substitute these values into the equation there. So I could call this equation 1. I'm going to substitute those values into equation 1. Before I do that, I'm going to flip it one time. So I have 12P squared plus 9P Q is equal to A. This is the same equation 1. I just flip it. because I know I want to solve P. I like my unknown on the left hand side. So I write back 12. Instead of P, I am going to write, actually no, I will write back the P squared plus 9P. Instead of Q, I am going to put 2P because Q is equal to 2P. So I'm just replacing the letter Q with 2P. So I will have everything in terms of P and I could just solve for P. And that is equal to 750 because A is equal to 750. I'm replacing A with 750 as well. So I now have 12P squared plus 9 by 2 is 18 and P by P is P squared is equal to 750. Now 12P squared plus 18P squared is 20. No, it's 30P squared, my bad. It's 30. 12 plus 18 is 30. So 30P squared. And that is equal to 750. So P squared is equal to 750 divided by 30. P squared is equal, when you divide that there, you should get 25. Now if P squared is equal to 25, you need to find the square root of both sides to solve for P, because you just want to solve P. So the square root of P squared is equal to the square root of 25. And this will give you P is equal to plus or minus 5. But remember, from the diagram, P is length. Length is a scalar quantity. Length cannot be negative, so you will just take the positive value, which is positive 5. So P is equal to 5 units. Right? And that is basically the answer there for that. And this is a total of 9 marks as well for this entire question too. Algebra. Right?